My name is Umar Javed, and these are my group members' names. So I'm going to start with the executive summary of our project. The dataset provides a detailed analysis of factors influencing auto pricing, highlight key performance indicator, and market dynamics. Today I'm going to talk about the factor that influence auto pricing based on the data we analyzed. So I'm going to start with the pricing overview. As you can see, the average price of car in our dataset is 13,277. However, the distribution is highly variable, meaning there's a wide range of price. We have categorized these into three segments: low end, mid range, and high end. The low end car price below 7,788, these are typically efficiency focused vehicle, and the mid range cars price between 7,788 and 16,503, these balance affordability and performance. And the last one is high end. So car price about 16,503 premium features. These are these offers premium features and luxury cars. So in the second, I'm going to talk about the performance indicator. Our analysis shows that engine size and horsepower and strongly correlated with the price. Larger engines and higher horsepower generally lead to higher price. So additionally, higher curb weight often associated with the safety features and luxury. So fuel efficiency, if I talk about the fuel efficiency, interestingly, we found a negative correlation between fuel efficiency and price. Moreover, fuel efficiency vehicle tend to less expensive, and fuel type. Finally, we look at the impact of fuel type on pricing. Gasoline vehicles average 12,1999, while diesel cars are slightly more expensive at 15,838. So these are dimensions and features, size and wheelbase. Sorry, size and wheelbase cars. Size and wheelbase. Larger cars with longer wheelbase tend to be more expensive. This is due to increased manufacturing costs and the perception of luxury associated with the large vehicles. And premium design cars with high quality materials, advanced technology, and sophisticated design command higher prices. Strategic insights focus on premium feature for high-end market. Based on our analysis, here are some strategic insight for our auto manufacturers. Target the high-end market, focus on developing vehicles with premium features, advanced technology, and luxurious design to cater to high-end buyers. Offer fuel efficiency option, introduced fuel efficient compact cars to attract budget conscious and consumers seeking affordable and environmental friendly vehicles. So now I'm going to talk about the literature review of our project. First, we explored macroeconomic factor. Research shows that GDP growth about 3% above correlates with the increased car sales and driven by higher consumer confidence and purchasing power. Economic stability also plays a critical role in shaping consumer spending pattern. Next, under technological and structural determinants, factor like vehicle age, mileage, and engine type are pivotal role in pricing. Additionally, machine learning models now achieve over 95% accuracy in predicting car prices, showing the power of advanced analytics. Electric car vehicle on or EVC are particularly sensitive to price and government incentives. So, in terms of market and consumer behavior, developed market prioritize safety and brand values, whereas emerging market emphasize affordability. And urbanization is further driving demand for compact, low emission vehicles. Moving on to digital and dynamic pricing, over 95% of used car Search start online dynamic pricing algorithms are now widely used to adjust price based on demand, inventory, and geography, enhancing profitability by around 2%. Lastly, global influence like supply chain, distribution, and inflation have increased demand for used car. Additionally, regional demand variation influence vehicle pricing strategies. However, there are notable research gaps and sustainability and EV impact are limited. So, more demographic specific behavior analysis are needed in emerging market long-term pricing and however, there are notable research gaps, studies on sustainability, like long-term pricing, trend also remain unexpected, and future research should focus on these areas to address global shift deeply.
Hello. In this part, I want to talk about understanding the determinants of car prices and feature-based analysis. In today's competitive market, what drives car price? We all want to know. Our study dives deep into the key determinants, offering a perfect roadmap for manufacturers to optimize designs and pricing strategies. The first feature that I want to talk about is the car size. Dimensions like length, curb weight, wheelbase that directly influence the cost. By tailoring the size of market trends, manufacturers can target specific segments more effectively. The second feature that I want to talk about is engine specs. Variables such as horsepower, engine size, compression ratio, it balances the performance as we all know, and it is highly efficient and critical factor in justifying the premium pricing. Fuel efficiency, CT and highway mileage, along with the fuel type, are the vital for aligning with eco-conscious trends and driving sustainable innovation. The fourth feature that I want to talk about is body type and its driving. With the SUVs leading the market growth, understanding the car pricing dynamics of a body type and drivable configuration ensures investment aligned with the consumer demand. Fifth feature that I want to talk about is its design and its aesthetics. Features like toe count, engine placement, aspirations types differentiate brands, enhancing consumer valuation in crowded markets. This analysis is backed by the market trends literature that highlight the increasing importance of engine performance, sustainability, and dominance of high demand body types. Unlocking this insight empowers the manufacturers to stay ahead in the pricing and design.
Okay, in this part, I will introduce how we process our data. The file contains multiple sheets, including car price assignment is the raw data, and the pivot table is a summary for categorical variable impacts. And the car price processed is the process data. In the car price assignment sheet, it contains original data set with 26 columns, and it specifies the car specifications and the price. Firstly, we removed the nominal data because the car ID, symboling, and the car number, these variables are not usable in regression analysis, so they are removed. And secondly, we noticed that the car price contains some outliers and is a right-screwed distribution. So we took the logarithm of the car price to stabilize the variance and normalize the distribution. And thirdly, the car price processed sheet includes additional binary columns. The adjective field type and adjective aspiration is for the category variables converted into numerical form. The pivot data identifies category variables, field type, aspiration, and we think that they are significantly influence the target variable price. So these variables are nominal, but represent distinct car pressures with potential pricing impacts. Their inclusion is necessary, but regression models require nominal representation. So category variables were replaced with binary indicators. We use 1 and 0 to represent their presence or absence. Firstly, in the car price process sheet, correlation analysis was conducted. Among variables that influence price, The objective was to identify and address the situation where independent variables are highly correlated, potentially distorting regression results. Highly correlated variables were identified and selectively removed to ensure the stability and the interpretability of regression model. This step prevents the distortion of coefficients estimates and enhances the reliability of the analysis.
Next, we're going to talk about the exploratory data analysis. To better understand the distribution of important numerical data values, we began by creating a box plot of car prices. The box plot revealed a wide range of prices with a few outliers on the higher end. These outliers represent high-performance vehicles with higher prices compared to the majority of cars in the dataset. Additionally, we create a histogram and observe a right-scale distribution of car prices. Outlier can negatively impact model predictions. So to avoid this, we applied a log transformation to the price variable. After applying the transformation, the box plot of prices show a more centered distribution with no obvious outliers. By compressing extreme values, the log transformation enhanced the fit of the regression model, leading to more accurate predictions. Next, we analyze categorical variable by using pivot tables to identify the impact on car prices. To prepare this variable for use in the regression model, we transform them into binary indicators. Conditional formatting was used to identify and highlight the categorical variable with highest counts, which were assigned to a value of 1, while the remaining category were assigned to a value of 0. This binary transformation made the categorical data suitable for regression analysis, improving the model's ability to predict prices. The correlation chart offered a visual representation of relationship between variables in the dataset. After generating the correlation chart, we used conditional formatting to highlight variables with correlation higher than 0.5. This made it easier to identify patterns and relationships. For instance, variables like highway MPG and city MPG were highly correlated with each other, but not strongly correlated with the price. Retaining both variables could undermine the accuracy of predictions. So as a result, we decided to remove those highly correlated variables. And lastly, we created scatter plots to validate the result of regression model and gain further insight into the relationship between variables. Scatter plots help us to evaluate trends and identify outliers. So the first scatter plot showed the relationship between price and horsepower. The points and trend line revealed a strong positive correlation. As horsepower increased, car prices also increased. So this clear and consistent trend indicated a horsepower is a highly predictive variable for prices. And the second scatter plot on the right examined the relationship between price and wheelbase. While this plot also showed a positive trend line, the trend line was much weaker compared to the price horsepower relationship.
The next part is predictive analysis. The study predicts car prices by using the categorical and numerical data variables to assist the manufacturers in price strategy and provide customers with price guidance for informed decisions. This study involved a data set of 205 cars and data collected via stratified sampling. It identified 7 variables that potentially affected car prices. This variable include fuel type, aspiration type, drive wheel type, engine location, engine type, wheelbase, and horsepower. Using 3 factors, we develop a regression model expressed as log price equal to 2.78 plus 0.11 xy plus 0.04 x2 minus 0.07 x3 minus 0.20 x4 plus 0.04 x5 plus 0.01 x6 plus 0.004 x7. The results are impressive with an R-squared value of 0.86. The model explains 86% of the variation in car prices, indicating a strong fit. The F statistics significance level of 0.00 confirms that the regression is statistically significant. Key findings reveal several interesting relationships. For instance, the coefficient for fuel type is negative, showing that cars using regular fuel are priced lower than those using diesel. Similarly, front-wheel drive cars and vehicles with front engine location negatively impact car prices. On the other hand, standard aspiration, OHC engine type, larger wheelbase, and higher horsepower positively influence car prices. We also conclude hypothesis test for each variable. All p-values were below 0.05, meaning every variable significantly contributes to the model and should be retained. While the model performs well statistically and align with the theoretical expectations, some errors should be improved. For example, the aspiration variables should relatively low significance, even though prior studies suggest its importance. Furthermore, some unobserved or collineal variables might be influencing the results, potentially introducing bias. In conclusion, this regression model provides a robust framework for understanding car price determinants. It offers valuable insights for manufacturers, dealers, and buyers. However, addressing areas like exploring additional factors could further enhance the model's accuracy.
In this part, I want to talk about the implication, conclusion, and next step for business leaders. First of all, the implications for business leaders. In today's competitive landscape, business leaders must adopt tailored strategies. First one is design strategy. They should customize an aesthetic to align with the distinct market segments. Second, they should focus on the engine. They should balance the performance and efficiency to meet the consumer priorities. Future trends, they should innovate to capture the rising demands for SUV and focused features. In conclusion, I would like to say that this study bridges the academic insights with practical applications, emphasizing how theoretical framework can shape pricing strategies for modern markets. It highlights the vital link between research, real-world decision, equipping stakeholders with actionable strategies. The recommendation for stakeholders is that first, they should invest in research and development to develop sustainable technologies and enhance high-performance engines. Second is refining marketing strategies. They should spotlight features that resonate with targeted segments. Third is that they should develop data-driven pricing models to remain agile and competitive in shifting markets. Limitation and future research. This study acknowledges certain limitations, such as narrow focuses on emerging technologies like EVs and the lack of regional and demographic specific insights. Future research should explore evolving consumer preferences and incorporate advanced technological innovations to provide deeper insights.